All right, hello everybody, and welcome to the topic 6 notes on algebraic expressions, where we are going to continue where we left off on Thursday. So we're going to start with a little warm up here, where we're going to take a look at just taking some expressions and simplifying them. So when we look at our first example here, we have negative 3x minus 18 plus 4. So let's zoom in. What we can see is that we can actually simplify this part of the expression. So we can simplify it down that negative 3x does not change. And then negative 18 plus 4 gives us negative 14. So again, just a nice warm up for what we've already done so far. For question B, we're going to do the same thing. We're going to see if we have any like terms, which we do. And we're going to simplify those. So 5y minus y is going to give us 4y. And then that minus 3 stays the same. In question C, same thing. We're going to identify like terms and see if we can simplify those, which we can. And then the rest, we have a constant. And then we also have another variable, which we can't simplify any further. So negative 2x plus 1 is going to give us negative x, or negative 1x if you want to think of it that way. And then negative 2 is going to stay, and plus y is going to stay as well. So that's a nice little warm up, basically reviewing some questions that we already worked on Thursday. Okay, so now what we're going to do is we're going to move a little bit further, and we're going to look at simplifying expressions where we're clearing parentheses or brackets. So as we know, some expressions are going to contain brackets, and these brackets or parentheses need to be cleared or removed before the expression can be simplified. So to clear brackets, we're going to use the distributive property. So this is another property adding on to the commutative and the associative property that we spoke about on Thursday. And so for this property, again, we're going to be given A, B, and C, which are real numbers. And we're going to see that these three statements stay true. So again, our left side is going to equal our right side. So this property basically allows us to distribute, in this case, the A into the bracket in order to open up that bracket. So rather than A times bracket B plus C, we can also write that as A times B plus A times C. And again, that remains the same idea if in the bracket it's subtraction rather than addition. Same idea. This time we would have AB minus AC. So the left side equals the right side. And similar to our associative rule, the order that we do that multiplication also doesn't matter. So we can also think of it this way, where we could distribute and open up the bracket as B times A plus C times A, which again is that our right side. So our left side equals our right side for the distributive property as well. So this example that we have here of 6 times bracket 2 plus 3, we could rewrite it as such as well, and that would be correct. So for the next 3 examples here, these 3 expressions, we are going to expand them, which means essentially to distribute the 3 into the bracket. So this is going to become 3 times x, which is just 3x, and then 3 times 4, which is 3 times 4. So we can simplify this down to 3x plus 12. So that same idea we're going to repeat for the next 2. Again, we're going to distribute that 5 into the bracket to open it up. So we have 5 times 7, which is, which is 35. And then 5 minus 5m. And again, our next example here, a little bit different. We have negative 2, and we're going to distribute that into the bracket as well to open it up. So make sure we capture the negative as well as the 2. So this becomes negative 2x and then negative 14. because negative 2 times positive 7 gives us negative 14. Okay, so this set of notes, lots of practice questions. So we're going to start working through those now. So because this is a video, which is really nice, you can certainly pause it and try these questions yourself and then watch the video to see if your answers match. Or certainly you can fast forward as well if you've done all these answers and you're feeling confident. But this set of notes has a lot of practice questions. Okay, so for these next 6 examples, we're just expanding. And again, we're just going to use that distribution property. So this is going to become 2x minus 6. Even if that number is a decimal number, it still applies. We still just distribute it into the bracket to open up the bracket. So we'll have 0.25n plus 3. And again, the order doesn't matter. So we can also do it the other way. So this will be x times p plus 8 times p. So 8p or xp, pardon me, plus 8p. And sometimes what we have in front of the bracket here does have a variable as well. So in this case, we're also going to distribute, but we can use our exponent rules as well to simplify this. So this is going to be 3x times 3x. So 3 times 3 is 9. X times x is x squared. And then 3x times negative 8 is going to give us negative 24x. Carrying on for E, we've got a bracket that has actually 3 terms in it. Same thing, we're going to capture this negative 2 and we are going to distribute it into the bracket for each of those 3 terms. And we end up with negative 8a minus 2b plus 2. Carrying on for F, we have this negative in front of the bracket. Well, what does that mean? We can think of it, if it's helpful, to think of it as a negative 1. And we're going to still distribute that into the bracket. And what happens is that when we've got that negative, it just changes the sign. So we're going to have negative 3x cubed, and then a negative times negative is going to give us positive 2y. So those are 6 good examples, and then we have some more practice questions here as well. Like I said, lots of questions to work through to help make sure that this is really solid. So for this practice question A, we're going to expand. So again, I'm going to expand by distributing into the bracket. So 100 times 0.3 is 30. 100 times 0.25q is going to be 25q. And then same with B. Notice there's that negative again that we're going to distribute in to the brackets. That's going to become negative x, negative 3, and then this last term plus 2xyz. Nothing changes with it. It's its own term. Question C, same thing. We're going to distribute the 4x into the bracket here. Again, there's also going to be some exponent rules that we can apply here. First one, 4x times 2x is going to give us 8x squared. 4x times 4x times 5xy is going to give us 20x squared y. Again, use the exponent rule there to make that change on the x. And then 4x times negative x is going to be negative 4x squared. And then 4x times 2 is going to give us 8x. And then we can't forget that plus 3 that was outside the bracket, because now everything's opened up. We can now collect our like terms. So we can see that we've got 8x squared, and we've got another like term of negative 4x squared. So we can simplify that down to 4x squared. We still keep the 20x squared y. That's a different term. Same with the plus 8x, and same with the constant 3. And that's as far as we can simplify that particular question. So, more practice. you're going to expand and then simplify these expressions. So you're going to make sure that you open up that bracket and then collect like terms for each of these questions. So again, you can stop the video and you can sort of check your work and see if you're following along and it's starting to catch on. So once I've distributed that 3 into the bracket and opened that bracket up, now I can collect my like terms. I have 3x and I have 2x. So using my commutative rule, I can bring them together and they can make 5x. And then plus 12 is the rest of my expression. Same idea for b. That 3y is going to stay the same, but I'm going to distribute that 2y into the bracket. So it's going to be plus 2yx and then plus 2y. Take a look. I've got some like terms that I can simplify. So I have 3y and 2y. So I can bring them together and make 5y and then plus 2yx. So same idea, continuing on. I'm going to keep my 5x. Can't change that. But I'm going to grab this -4 and I'm going to distribute it in. So -4 times 5 is going to give me -20. And then -4 times -x is going to give me plus 4x. So from here, I can see I've got a 5x and then a 4x. I can bring them together for 9x and then still just -20. For D, that 8 right now has to just stay. I can't do anything with it. But then I can distribute this -2 into the bracket. I get -2x and then -2 times 3, -6. I've got 8 and I've got -6. I can simplify those and I get 2 minus 2x. Okay, so lots of practice, lots of using that distribution rule and then simplifying afterwards. So depending on the question, as you can see, we get further down on the page, we have a little bit more going on. So we're just building on these initial algebra skills so that as we move into more challenging expressions or equations, we have those skills in place to be able to solve. So with these next set of questions, you'll notice that there is more than one bracket. So we just have to distribute more than once. So for this first example, which should be example A, not B, so let me fix that. That should be an A. We're going to distribute that 2 into the first bracket and then distribute the 5 into the second bracket. So we get 2x plus 4 plus 5x plus 15. And then from here, we can say we have 2x, we have 5x, then we have 4, and we have 15. So we have identified our like terms. We can simplify them. So I get 7x plus 19. And that is my final answer. For B, same idea. We're going to distribute that 4 into the first bracket. And then distribute that -2 in the second bracket. And then from here, we're able to identify our like terms. And we can simplify this down to 2x minus 16. Question C, same idea. We'll distribute that 3 into the bracket. So we have 3x plus 12. Now here we have then subtract bracket 6 plus x. So again, sometimes it's helpful to think of that as like a 1, a -1. And we're going to distribute that in to the bracket so that it opens up that bracket. And what we get is -6 and then -8. And then from here, identify our like terms and simplify. So then we get 3x minus x, 2x. All right, so practice these. Again, same idea. Opening up the brackets, making sure that your answer matches mine. So for question A, you should get 14x plus 48. For question B, this simplifies down to x minus 2. And then for this big question C here where we've got 3 brackets, so we're just repeating that 3 times, that distribution rule. Your final answer here should be negative 5a plus 6. Now for each of these answers, please remember that the order of your terms can be different but still be true. So as an example for question C, this is your answer here, the negative 5a plus 6. But 6 minus 5a is also correct because that's using our commutative rule. So meaning we can move the order of those terms, but it still makes it equal. So those 2 answers are correct. We just put the a term first in the first answer and then the constant second, and then switched it around the other way. But notice that the signs are the same. The 5a is still negative and the 6 is still positive. All right, so these 2 as well, working through these. If you are distributing twice and then collecting like terms, again, the order of your terms can vary, but you should get an answer of negative 8a plus 2b minus 32c. And again, remember the order can be different. You could also have 2b minus 8a minus 32c, or minus 32c plus 2b minus 8a. These are all the same and they're all correct. It's just the order of your terms. Okay, this last one, E, has some fractions. So this one is definitely the most challenging so far that we've taken a look at. And definitely there's different ways of approaching this question. I'm going to break this down into some steps so that you can see, but certainly some of you might be able to jump a little faster through this process. So similar to if it was just a number, even if it's a fraction in front of that bracket, we're still going to distribute that in order to open up that bracket. So our first bracket is going to look like 1 over 2 times x. Well, that is the same as x over 2. Now, 1.5 times 4 is the same as 4 over 2. Negative 1/3 times 12 is the same as negative 12 over 3. And then negative 1/3 times negative x, 2 negatives make a positive, is the same as x over 3. Now, at this point, we do have some like terms that we can bring together and then to simplify. So we have an x term here. I know it looks weird because it's fraction form, but it's still an x term, and these are still like terms. And then these constants, so just numbers in the middle, are the same. Now, right away, some of you might notice that, well, I can simplify 4 over 2. That's just 4 divided by 2. That's the same as 2. And negative 12 over 3, well, that's 12 divided by 3. That's the same as negative 4. And then we have our plus x over 3. So certainly, you might right away simplify this because it's just numbers. It's easy to do. So let's bring our x over 2 close to our x over 3. And then we will simplify. 2 minus 4 is going to give us minus 2. Okay, so we've simplified our constants. We can't simplify that negative 2 anymore, but we certainly can simplify these two like terms. So they are in fraction form, and we haven't talked yet so much in class about fractions, but hopefully you remember in order to add or subtract fractions, you need to have a common denominator. So our common denominator for these two sets of fractions, one has a denominator of 2, one has a denominator of 3. So we can easily come up with a common denominator by simply thinking 2 times 3, which is 6. So what that means is that we need to make some equivalent fractions. So I can take my first fraction. If I multiply the top and the bottom by 3, that's going to give me a denominator of 6. And then for my second fraction, if I multiply the top and the bottom by 2, that's going to give me as well a 6 in the denominator. So from here, what does this mean? Well, 3 times x is just 3x. 3 times 2 is 6. X times 2 is 2x. 3 times 2 is 6. So now we have that common denominator of 6, which we need in order to add or subtract fractions. So from here, we can still simplify by now adding the 3x over 6 plus the 2x over 6. So when we have a common denominator, we just simply add our numerators. So this becomes 5x over 6 minus 2. Now you can stop here, and this would be absolutely correct. Some people might prefer to write this as 5 over 6 times x minus 2. It's absolutely the same and represents the same value. It's just written a little bit differently to separate essentially that coefficient from the x. So arguably the most challenging question so far to date. And as we move through the content and start working with fractions a little bit more, it will be helpful to maybe even come back and look at a question like this and try. Okay, for the last bit of this set of notes, we are going to look at these two expressions. Now, we're given that y is equal to 3, and we're asked to evaluate. So what I want you to notice about these two expressions is that they actually are the same thing. So if we look at the first one, negative 2 times 4y plus 1, we can see that we've got this bracket where for the second expression, the bracket has already been distributed. So the negative 2, you can see, has already been distributed, unlike the top. So we're doing both of these just to show how, if we have our value for 3, there's so many different ways that we can approach our algebra. So you could right away sub in the 3 for the y here. So for the first attempt, we could keep the bracket and do 4 times 3 plus 1. So again, remembering my order of operations, I'm going to do what's in the bracket first. So 4 times 3 is 12 plus 1, and then negative 2. What's in the bracket is 13, and we get an answer of negative 26. So that definitely could work. But let's say instead of just substituting in that y equals 3, what happens if we distributed first? Let's try it now. So for this example, we distribute out that negative 2 into the bracket, opened it all up. So from here, we could do the same thing. We could go through and continue to simplify this. So this is negative 8y minus 2. And then we could do the substitution for the 3. So then what we have, so negative 8 times 3 gives us negative 28. sorry, my bad. Negative 24, and then minus 2, and then we bring that all together, and that becomes negative 26. So either way, you're still getting the same answer. So we just use this to highlight different ways and understanding that there's always more than one way when it comes to algebra and when it comes to solving. So the more practice you have, the more patterns you start to see and some things where you recognize and you know how to handle if it's brackets, parentheses, up here if it's fractions. As we work through more and more algebra, you're going to get more and more comfortable with it. All right, so that is the end of the video for today. Thank you for watching this. So everything up to this point now will be on activity 2. So as a reminder, that activity is due on Wednesday by 4 p.m. either to me personally or you can place it under my office door.